Welcome to ARVN, Amateur Radio Video News. The program you're about to see is free to watch, courtesy of YouTube. Thanks, YouTube. But it wasn't free to make. ARVN's got a lot of money invested in video equipment like this sweet camera and that editing system back there. And it takes a lot of time to shoot and edit a program like this. So I'm asking you to make a voluntary payment, contribution, whatever you want to call it. Just stop by our website, arvn.tv, and you'll see a link to make that payment, whatever you think the program is worth to you. I guess you could say that this program is brought to you by you. So thanks for watching and enjoy the show.
Bob has the advantage. He has 10 times more energy than I do, and I didn't have any caffeine this morning because they ran out of coffee. So bear with me as I try and bring myself up here. It was very unfair. They hid it downstairs. Okay. Before the conference, I had gotten emails from Bob, and he's a smart guy, and he's been throwing around ideas here on how can we do call sign based connectivity. And what I had here was just kind of a distillation of some of the things that I had emailed him. I just cleaned it up a little bit, basically, but. There are a number of things I was just going to say that tie in with what Bob has talked about, and then a lot of these other things are really just kind of, as I title it, just food for thought, a wish list, things that I kind of wish D-Star had. So I think you'll see some overlaps in the things that Bob has been talking about here. Okay. One of the frustrations that I have with D-Star, if you look at how the D-Star framing is set up here, they do a good job of protecting the call sign routing information that actually has interleaving on it, has scrambling on it. The AMBI codec does internally forward error correction. It does a rate 1/2 convolutional encoder inside there. But the data streams, the stuff that goes across, as far as any of your messages or even your other, keyboard to keyboard chat type stuff or whatever, has no forward error correction on it. I think they did it out of laziness, and I think they did it just out of overhead. But, originally I wasn't going to call this food for thought. I was going to call it If I Was King, but I thought that was pretentious. Is that what we really want is forward error correction on everything that we send, not just the voice. The one thing I'd like to see, and I know others have said this, I'm not omniscient on this, what goes out on D-Star is the voice content with the overhead of forward error correction takes up the equivalent of about 3,600 bits per second worth of capacity. The other 1,200 bits per second of capacity is associated with data, whether it's GPS or text-to-text messaging. And the one thing I would like to see or just have a hook into is just having, essentially just treat a D-Star radio as just a 4,800 bit per second data pipe, so we can push whatever we want through it. So I figure if you just do rate 1/2 encoding, you're talking about an effective throughput at around 2,400 bits per second. The advantage is now we're using forward error correction, so you're going to get better reliability in your links. This is really a dig against Icom, the manufacturer, and I say build radios equipped with a D-Star only display mode. Okay. You would think for radios that were designed, for this new premier technology or whatever, that would be highlighted. And it's interesting as I look at the Kenwood radios that Bob's shown with APRS, you can see where APRS was really built in as a dominant feature for those radios. And what bothers me with the D-Star radios that are out there, all of these things that are D-Star related are buried in submenus. They are not the dominant element that shows up on a display. So if I could change things, I would say we need a radio that just had an emphasis on the user interface with a D-Star display. So ideally, you should be able to see, the call sign information, the routing information here, and if somebody's sending you a message, you should be able to just see, their call sign and just see the message without having to see the frequency display and, you know, if it's a negative offset for the repeater or whatever. I would just like to be able to see the information. And unfortunately, the way they do this in D-Star is that the messages are basically just scrolled across the bottom of the screen. It's really of secondary importance. The whole thrust of it was really onto the digital voice side, but I'm saying here in the US especially, I think there's a lot more interest in trying to leverage text information. We're passing things that you know, it's just too overwhelming to try and do just by voice alone. And especially if you're doing like a special event or a medical emergency, if you had to type in the complex name of some medication or something like that, trying to say that, you know, it can be quite tedious. One of the other thoughts that I had would be a better way, and this kind of ties in with what Bob has been saying here with APRS, that you can actually have the information show up as far as what repeaters are available, how far away you are from something. In D-Star, you don't have that. You know, basically, you have to know where your repeaters are. You've got to go to an ARRL repeater directory or some other local directory. And it's just like programming in any other radio. You got to go in and put in the frequency, the call sign, the offset. All right. You don't know where you are. And I would say probably the best example I had of this, and this is also kind of overlapping with some of the things that Bob had talked about. For business a couple of months ago, the company I work for is based in Syracuse, New York, and I was supposed to fly, and United Airlines did its utmost to completely destroy my travel arrangements. And in angst and frustration, I left the airport after having missed the flight and went back home, called up the travel agency that our company works with and said, I missed the flight and this is all screwed up or whatever. And I said, screw this, I'm driving. So I got in my car, left at 3 in the afternoon, got to Syracuse at 11 o'clock at night, and I was just flying down the road basically, just trying to get there. But then on the way back down, I thought, well, okay, I got a little bit more time. So I tried looking ahead in some of the repeater directories and programming things. So if you look at the hassle, if you're actually driving through an area, all right, if you want to just keep tuning around, the problem is all our radios are set up to be channelized as opposed to actually watching a swath of frequencies. How do you know where the PL tones are? Okay, and it's not something you can really do on the fly, all right, without taking your life in your hands of actually trying to go into the radios and submenus and change PL tones, all right, and that type of thing or whatever. So it was really kind of irritating because I'd drive around and I thought, oh, okay, I hear somebody talking on a repeater, but then I realized I don't have the right PL tone in there. I don't know what the PL tone is. I'm driving the car at 60 miles an hour. I don't have time to open the book, to figure out what's going on here. And the thing that I always wanted after that experience was I would really just like repeaters to sort of beacon out this information. Just tell you, basically either you have a calling channel or you have a mechanism, even if you're just scanning around, that they broadcast and populate this information into your radios. So I'm just saying what I would like to see are these either a central beacon station in a metropolitan area or some area, or the individual repeaters themselves, to just load our radios ahead of time. So as you're driving in and out of an area, you're loaded up. You have all the information so that you don't have to have these directories. But basically what I want are radios to discover their nearest repeater, or in the D-Star case, the nearest hotspot, without having to rely on our printed directories that we do today. And let these repeaters broadcast, their call signs. So, right now, what do you have? You have a repeater that if nobody's on, the repeater doesn't do anything. It's just sitting there, all right? So first of all, you got to go find it, but after you found it, you're going to transmit, you're going to do something, and then periodically it's going to do the FCC thing, it's going to have to ID itself or whatever. And I'm saying there's a lot of dead time. We have repeaters just sitting there doing nothing. It's like, why don't they broadcast during these, what I call non-traffic times, where you're not having hams talking to each other, just broadcast and put out this information and load up our radios. So, like I said, I just see it as this complement to the standard repeater ID where once an hour or something you get, this is the W4OV8 blah blah repeater. Clunk. Okay. Okay, one of the other things that's frustrated me with D-Star is, and actually trying to set up and test things and diagnose it, it's really very difficult to try and split the problem, you know, as far as, am I running into an RF problem, am I running into a gateway connection problem, am I running into a radio problem? There were issues that were going on, and especially in the Port B or the 440 megahertz radios for a while within the way ICOM built them. If you actually ever open up a D-Star repeater, it's literally 2 mobile rigs just inside of a box, okay, with a little controller board in between there. And believe it or not, the cabling that they had internal to the box was the lowest grade RG58 cable you could buy. And what was happening was the RF from the transmit side was leaking into the coax of the receive side and was blinding the radio. So eventually a lot of hams kind of figured out what was going on, and then you started seeing these mods showing up on the internet, and people were ripping those out, and they were putting in like semi-rigid cable or double shielded cable or whatever. And then finally, believe it or not, ICOM saw the light and actually changed their manufacturing process and actually put in better shielded cables, okay? So, but you know, you ran into this problem as far as, well, how do I split the problem and figure out what's going wrong? And unfortunately, in all the D-Star stuff, they don't really have any sort of test or diagnostic modes, as strange as that sounds. They have a jack or a USB port in the front that you use for programming the information, but they don't have any diagnostics at all. So one of the things I really would like to see within D-Star is something that's really akin to your traditional bit error rate test, where you can actually just, at the 4800 bit per second link or whatever, just put out some sequence and actually test out your radios, your radio links, all right? And then you can also split the problem and actually see and examine what packet traffic is coming across your gateway connection. But as it stands today, they don't do that. They sell you this turnkey widget, and if it works and you got it all configured, and then you say, well, it works and I'm done. Well, that doesn't do you any good if you need to fix something. My dig. Have a manufacturer other than ICOM build an embedded D-Star radio module for experimenters. And my comment there is ICOM doesn't seem to have any interest in actually trying to build modules, but I'm saying here is a group of experimenters that I think if, as hams, if we came out with just a small module we could embed in our own customized designs, where we can use our own displays, whether we use a laptop, whether we use LCD displays, whether we use keyboards, whether we use whatever means of data entry or user interface we select, but just have just a generic radio module that we can just talk to and just put in our information, just control it, and leave out all of the other niceties, if you will, of a case, you know, a logo, the keypad. We can do whatever we want if we just have this embedded module. I mean, we're doing it today for small Bluetooth interface modules, we do it for Wi-Fi modules, we do it for other short-range radio stuff or whatever. It would just be nice to have just a brick that is just a D-Star brick that we could just build in, and as experimenters we could work with it. I think that would also be a good jumping off point to actually get another manufacturer other than ICOM involved, which I think would help D-Star grow if you started having at least one other commercial vendor out there actually doing something. Another one too is in the ID1s, that's the higher speed 1.2 gigahertz radios, they transmit the data at 128 kilobits a second. The connection that goes into the radio is actually an Ethernet port, all right? And all they do is they basically just take all of the Ethernet data and then they just wrap around that the radio routing information. But there is no other error correction done. They just rely on the CRC that's within an Ethernet frame, and if it says, sorry, bad Ethernet frame, you got to go back and retransmit or whatever. So this kind of ties back into my whole comment that we're not really taking advantage of, you know, even just rudimentary forward error correction to really help, you know, make our links more robust. So that would be another I wish type of thing. Now, if I was really going to dream great dreams here, you know, we have a lot of people who are doing work with digital signal processing. And, you know, if you look at if you had as a repeater to just pass along the raw data stream, if you have a 4,800 bit per second GMSK signal that's just moving along here, it doesn't take a whole lot of horsepower to actually do anything with just that raw stream, which you're then just rebroadcasting or retransmitting over some area. You know, the biggest problem that I have, that I feel that we have in ham radio, at least in the urban environments, and I was talking to the gentleman from the FCC, you know, is that in more cases we're actually geographically limited as opposed to just frequency limited. There are very few sites available anymore that are really decent enough to serve as a repeater location. It used to be much more straightforward for hams to be able to hook onto somebody's tower somewhere or be allowed to go up on a tall building and put in a site and maybe do some sort of thing like, yeah, we'll paint the outside of the top of the building or whatever to help you clean it up or whatever in exchange for you providing us a little place to put our repeater gear. All of that's become prime real estate. And it's become prime real estate for all the commercial services, in particular cell phones. So the problem is, you know, and we've run into this with our club down in Manassas, is that we wanted to find a site for the D-Star repeater. And, you know, we went to the city of Manassas and other places and we said, could we set up stuff on a water tower in town or whatever? And they said, yeah, if you pay us $1,000 a month, you know. And it was, okay, you know what I mean? So they're not interested in really helping the ham community if they feel that they can sell this as prime real estate. In the end, we ended up putting the D-Star repeater and basically just replacing the packet station that we had that was in a little shack that was at a water tower, you know, that we just had prior arrangements. So we just said we're upgrading our equipment, all right? Okay, but you know, I mean, and even then, it took enough effort just for us as a club to actually make all the arrangements to bring in a DSL line to just serve for the gateway connection, you know. So real estate, you know, this geographical reuse, I think is going to be just about as important as frequency reuse, and that's one of the selling points of D-Star. By virtue of being more narrowband, you get greater frequency reuse or spectral efficiency. So, I mean, the things I'd like to really see is people actually working within the passband of existing duplexers for our wideband analog radios today. You can fit 2 D-Star signals within the bandwidth of a conventional analog FM signal. You could also, if you do your repeater right with DSP, you could also pass D-Star on one side and pass something like narrowband FM on the other side, and just share all the same amplifiers, the same antennas, the same duplexers. But to separate this out, basically, you're going to need all the filtering that you would do within DSP to keep these two, you know, living happily ever after, if you will. But the way I see it is that would help us in doubling the capacity from the geographical aspect. Okay, we're now leveraging a good site. You know, the few good sites that we have, we could leverage our good sites to use them more effectively. One other thought too, and this is kind of tying in with the presentation on the codec 2. It's interesting, some people like or are used to the audio in D-Star. A lot of work is, what was his name, David was talking about with codec 2 about you know, how difficult it is to start compressing audio and get the fidelity out of the audio as you start going to lower and lower bit rates. You know, D-Star took that plunge, went down that path, you know, went for the gold, if you will, to actually try and minimize the bandwidth. All right. But some people really do not like the audio quality that's coming out of the Ambi chip. Part of it is you get used to it after a while, you know, and there is a difference between analog FM or whatever. Well, the point is, the chip that we're using today, you know, in there is capable of supporting higher bit rates. So I'm saying maybe something we want to actually consider is also kind of going back in the other direction. If we were willing to go back up to, let's say, 12.5 kilohertz channel spacing instead of 6.25 kilohertz channel spacing, well, maybe we could actually support a higher bit rate and higher quality or higher fidelity audio. You know, I remember a couple of years ago going to Dayton. I go back to Dayton each year. You know, and there was a demonstration of the AOR digital modems that they had, and I was literally just blown away at the fidelity of the audio that they were playing in this HF link. The disadvantage of that whole system was that really to make it work right, you really need a high enough signal to noise ratio to keep everything, you know, kind of running right or whatever. But the point is the codec that they're using, I think, is similar to or a variant of the AMB chip here. So the point is you have the capability of actually having higher quality, higher fidelity audio. It's interesting in some of the early experiments that went on with the DV adapter, the digital voice adapter that Satoshi, if you just ever type in Satoshi and D-Star, you'll find all of his previous references. But some guys in our club actually built up some of those boards, kind of monkeyed these around, and we were surprised actually at how much better the audio actually sounded as compared to what ICOM was doing. So the ICOM radios apparently are doing a lot in actually trying to filter or passband limit the audio that's actually going into the you know, their D-Star radios. So this might actually be a good jumping off point of actually starting to consider the use of digital audio, but this time use an open standard like Codec 2 and actually try and implement that. And maybe one of our hooks or selling points is, why don't we use Codec 2 as a higher fidelity mode and try and tie it in with some of the things that Bob has been talking about. Okay. One of the things, I've never found out why, but initially there was work done in building this digital voice adapter, and Satoshi in Japan was one of the first people to do that, and then for whatever reason he just dropped it. I never found out why. There is a group in the Netherlands, if you ever type in Dutch Star and D-Star, you'll find a list, and there's a group in the Netherlands that I believe is on the verge of actually trying to remanufacture or build another replacement, if you will, for this, but I think it's still in the planning stage. I don't think they're selling it yet. But the point is, the nice thing about these digital voice adapters is that they, in essence, can work with the existing analog radio as we have today. So the way I kind of see this is that you could use 9600 baud packet ports on these existing radios as now our common IF or interface point. All right, we've got them. So, for example, I use the hotspot that I run at home. I bought an old Yaesu FT2600. It has a 9600 baud packet port. Bought a hotspot board. It's actually called the Not Quite So Mini Hotspot. Just hook that up to the radio 9600 baud port. The other side goes to my computer, which is hooked up to the internet, and that's how I do my access to the D-Star gateways. Okay. So, but my other comment is that I don't think it's reasonable. You know, the D-Star crowd is very rah-rah D-Star, and I don't think it's realistic that people are just going to all of a sudden see the light, you know, there will be a beam of sunshine that comes down and people just automatically throw all their radios away. I mean, that isn't realistic, okay? So I really see it that for probably at least 10 years or so, I think you're going to see this transition period, and I think we ought to leverage this. We have radios that have these 9600 baud packet ports. Why don't we use them and use them more effectively? All right. You know, and in some ways, as Bob was talking about a lot of things too, the one theme that I have, one of the complaints I always have about things is most of the user interfaces that we have to deal with are really bad. You know, we build a lot of things, you know, in radios, but the display is too small to see, especially if you're a mobile operator or you don't really have the controls, you know, that the human being would want. And that's really where I think if we're going to really start concentrating on other ways of doing our routing and stuff like that, it isn't so much on the RF interface side or even just passing the bits along. It's how does the user use the radio or the device or whatever? It's that user interface, and trying to make it very user-friendly is really the key. I know I saw the demo of the, what was it, the YAG tracker display, the little box or whatever, and I was suggesting that they actually just take that, just take out the 1200 baud TNC that's in there, and just use that for just displaying the digital data that comes out of a D-Star radio. And I'm telling you, the guy who wrote the software for that, he nailed it. He did a really nice, clean job of building a very simple, very readable user interface. And that's been my frustration, not just with ICOM, but so many of the other conventional radio manufacturers. I don't know what they're thinking for us. You know, everything is buried in menus and sub-menus, and you know, I find if you're trying to do any of this stuff while you're driving around, you're taking your life in your own hands. You know, it's just too distracting. So kind of shifting gears here. The battery or switch is getting a little weak here. You know, as I was saying, you know, prime real estate is really getting hard to find. And in some ways, I think we're going to have to start looking at other approaches for ham radio here, other than spending all the money to buy one really good site that now is becoming really almost impossible to find. So one of the first attempts that we did as in ham radios, we started setting up things like Echolink and ARRL nodes as local nodes in our homes. All right, so we could just have our home computer, we could have, you know, our radio or whatever at home, and then we could walk around or some local area with an HT and access that. And I really think realistically, this is a model that we're going to have to really start focusing on, as opposed to buying the stack or the box of whatever and finding the one great location and how do we power it. Especially for those of us that live in the urban and suburban areas, you know, maybe out in, you know, the rural areas or whatever, maybe it's easier to come by really prime locations. But around here, tower space, building rooftops or whatever, it's prime real estate, and you're really, really being hammered now to try and find a decent spot. And the two challenges you have with D-Star, at least like in the Washington, D.C. area, is find a decent location and then find a place or a method to get the internet access you need for the gateway. That's actually, those are really the two key things that are really, I think, limiting a lot of the adoption of D-Star, is just finding a decent place to do that. You have so many other existing 2-meter or whatever 440 analog repeaters that are out there. And people just camp on them, and they just kind of sort of, they're there, you know, and maybe they get used a little bit here or there or whatever. You know, but when you say, okay, we'd like to change things, well, I'm not giving that up. Yeah. So one of the thoughts is, if we just start using things like the hotspots, and if we could actually come up with routing architectures where we could do like a cell type handover arrangement. I run a hotspot in my house. There's another guy who does stuff with the NCR D-Star group. You know, he's over in the Reston-Herndon area. He's got a hotspot. I mean, it would be nice if we actually had something where I could just move from one hotspot to another and just have these sort of low-level hotspot type sites or whatever that I could drive around into an area and do a handoff here, sort of just dropping out, changing frequency, going back, connecting back to where I was, you know, doing that whole thing. Okay. Now, Bob showed an interesting picture, and he showed me the picture when he emailed it to me at one point of the A-Star concept and trying to put something like a DV dongle at the repeater itself. So the idea is that you're going to just use all the existing analog radios today. People are driving around. The analog audio is going to come in. It's going to go into the radio. The audio will now be passed to a DV dongle, gets converted into D-Star audio, goes out to the world or whatever. And I said, well, okay, one of the concerns that you have, and this kind of goes back into the Gulliver's Travel side of D-Star versus, you know, the analog radio world is, you know, you have, in Gulliver's Travels, you have the little endians and the big endians, you know, which group, you know, opens the egg or whatever, you know. But this is kind of what Bob was saying. You had the D-Star camp, the digital purists, and then you have those who are the analog purists, if you will. And there are many people in the D-Star community that are just abhor the notion of actually ever trying to do any sort of analog audio being tied in with a digital network. And I said yesterday that if you look at D-Star, one of its prime advantages is that the audio is digital at the source, which means that you have the highest fidelity audio that you can, you digitize it, and now you've sent it out. Now the thing is, if you start having analog users coming in, all right, and then trying to digitize it, now you have the other noise, corruption, other things or whatever. So now the audio going in isn't going to be as good. But it actually begs the question, well, how good is good enough? And I think after this conversation or whatever, I think this is something I would actually like to research a little further, or maybe even try and do some experiments and kind of ask that question of how good does the audio really truly need to be before it's no longer good enough for D-Star use, if you will.
Well, I think there's maybe a little fraud here, because if you listen to D-Star, and especially if you listen to internet communications over D-Star, very often you're hearing, you know, it's all much too slow, it's not driving the codec correctly, etc. So to call these guys audio purists, I think it's fraud. I think they're just trying to expand having D-Star on the network by simply locking out anyone who's not D-Star and hoping that you will join D-Star to get into the club. So to a great extent, I think you can ignore that. The other thing is that I think a lot of people have started to realize that D-Star isn't a path forward for various reasons, and that is why you see ICOM giving away repeaters. You know, they will give your club the D-Star repeater that they used to charge $10,000 for if you just promise to install it.
Okay, but that's, I guess I'm not sure about the term fraud, but I mean, there are definitely those who are D-Star only proponents. I think there are elements of D-Star that people have come to like and have come to work with, especially like the call sign-based routing, the trust architecture, things like that. There is a lot of experimentation going on and trying to improve how we do our call sign-based routing. You know, and other than something like a DV dongle, there hasn't really been any other real experimentation with the audio side of D-Star. So I'm just saying, I think it would be interesting anyway, just as an experiment, would be what happens if you pass an audio from a remote location, you know, actually have some mobile user, analog FM user driving around, his audio comes into a repeater. Is there any way that you could say that this audio is now of good enough quality that it would actually be able to pass through something like a DV dongle or the Ambi chip or whatever and be of sufficient quality to actually go into the network? So the thought that I had was, okay, you know, with our analog radios today, we can transmit a PL tone. So one of the thoughts was maybe we could use as a signal quality metric, we could just look at something like the signal to noise ratio of a PL tone. So the PL tone is just sitting below the actual voice passband that we're working with here, and maybe just do some very, very simple little DSP thing to just look at signal to noise ratio and just say anybody below that point doesn't have a good enough signal to get in. You know, and kind of tying in with some of the things that Bob was talking about too here, you know, maybe there are advanced PL modes, maybe something more akin to the DTMF type modes or whatever. Maybe we actually just don't treat it as a continuous tone, but we actually do something where it's just coded data that we're sending out, you know, or like a DCS, you know, digital code squelch system or whatever. But just try and embed the call sign information and just tie that in as another point, of what we could use for actually trying to exchange call sign information to assist in the call sign-based routing. So it's something I would actually like to look at. I sent Bob a link to an experiment that was done, I think it was a D-Star group in Utah or whatever, and I think they used a DV dongle, and they just started mixing in some of their background noises that they thought you would contend with. Like they simulated, I think he had a fan or some other thing going in the background. And then he tried bringing up the noise level of the fan, as he was speaking or whatever, and then you start watching errors start showing up in the voice frames. And the problem is it was really kind of an artificial test. It wasn't the same as having a user driving around, listening to, the road noise or the noise if their windows are down, bless you, or just other, picket fencing or other things like that. It wasn't really a real world test. It was just somebody just kind of playing around with their home.
Well, it is definitely true that their codec won't handle noise, because we know from APCO 25, which has a very similar codec.
Yeah. And actually you bring up an interesting point that one of the things I know that they ran into the APCO 25 realm here was, I think it was firefighters and police were running into the problem of the sirens actually interfering, because a vocoder is looking at, and it's a model of your vocal tract. Well, what happens when you have sounds coming in that are not fitting that model or whatever? So one of the problems they were running into was the interference, and I'll use that in quotes, the interference that was occurring from things like the sirens that were present.
Chainsaw is worse. It's at the voice fundamental frequency.
Okay. Yeah. So I know DVSI was apparently having to kind of go back and try and figure out ways to work around that. So that's why I said I think it would be an interesting thing for us to try is if you actually did pass just analog audio through a normal RF link, how well would that really work? The other approach is kind of what I was talking about earlier of maybe we just end up doing our own codec, we just put it in through the 9600 baud port on an analog radio, and we just do digital audio that way. Any vocoder is a compromise. I mean, there's no two ways around it. Any vocoder is going to be a compromise, but its compromise is intended to lower the bit rate to allow you to use a specific radio channel. So, I think we as the ham community will have to decide what's good enough for us. Okay, and then lastly, my other thought is one of the things that is really slowing the adoption of D-Star is getting a gateway connection. And, and coupled that with that is the geographical location, finding a decent spot for a repeater. This is something I'd actually like to, push back either on, those that are tied in with, either DHS or some of the other emergency services, if that's their job by day is, are there things we can do, to try and get through grants, whether it's a state, federal, however, to actually get access to internet connections? If you look at how the Japanese were implementing D-Star, the whole gateway notion was really kind of a one-off. They really tried to show that all their repeaters are linked together in a microwave link backbone. And then they show just occasionally there's going to be one or two golden repeaters, that happen to have a gateway connection that go out to the internet. And that's not how we're using it here in the US. All right? We basically have either standalone repeaters or every repeater needs or wants a gateway connection. We do that because of the geography, in most of our areas here that really preclude us from having line-of-sight links. Plus, if you're going to do a line-of-sight link, you also have to have a decent enough location that's high enough up that you can actually see the other sites. And that goes back to the whole geographical thing. So, if you have other points here, it's how do you get internet connectivity? And that's really becoming the key limitation, I think, for slowing the adoption of D-Star technology. So the thing that I would wonder is there any way we can try and get some sort of state federal grants and actually have just greater recognition for whether it's D-Star or is just internet-based amateur radio technology, but are the things that could be done to help in actually getting a greater adoption of this concept. But, you know, for example, our group at one point did a little presentation to a Skywarn group at the National Weather Service, and I could see the government guy from the National Weather Service was very interested in what we were doing, and then we said, well, you know, this whole technology would really benefit if you had an internet connection. Well, because of all the, you know, security issues or whatever, it was like basically you're not going to get access to an internet connection on a government network, even if it's at the National Weather Service. You know, and that's kind of where I see, you know, if there's some way that this could be firewalled or whatever. We don't need a lot of bandwidth, you know, for what we're talking about here. So it's not like we're going to be really hogging their system. It's just getting people that have that existing infrastructure to just give us a spigot that we can use for interconnecting. So anyway, those were just kind of my collection of thoughts. Like I said, they overlap with things that Bob had talked about. You know, I think there are certain advantages that have come from the D-Star stuff. There's a lot of experimentation that's going on in the D-Star world. I think we're probably going to get to this point where there's going to be a D-Star 2.0 at some point here, where I think people are going to have learned enough and worked with enough of the frustrations or whatever of it that I think people want to start doing something new. And that's kind of where I'm just trying to throw out sort of my gripes or whatever, and then also try and tie it back into the topics that Bob has been raising here about the whole call sign-based routing. Okay, are there any questions? I'm going to just hand it off here. Yes, yes, sir.
Not familiar with D-Star because I've never used it, but I'm intrigued, and I think that there's extensive possibilities. Are you amplifying anything, or do you know of any amplification on the bit error rate that you were talking about earlier? Because with what I've heard with in my professional world with digital comms is that that digital quality gives you is almost kind of a bad thing in a sense, where if I know I'm in and then I walk 2 feet this way and all of a sudden I'm out. It would be nice to have some semblance of an S-meter or some operator interface to let you know that, in fact, you're not as comfortable as you think you are.
Yeah, yeah. That's, you know, that's actually, it's a good point. The most that they have today is with the D+ add-on to the gateway software is you can just do an echo test. I can transmit, you know, just say, hello, testing 1, 2, 3, 4, and it just plays back what I heard. So if you went to different locations, you would just be doing that same echo test. But there's no numeric display, you know what I mean? There's no quantitative value that comes back. You just listen to what's coming back, which is all very qualitative. You know, I think just having, at least at minimum, just a measuring mechanism or some quantitative numbers that you could collect would probably then let you start tying in and looking for some of those other characteristics, like you said. You know, if you start going around and sort of mapping an area or trying to find, you know, bad spots or whatever. But all I'm saying is right now, today, there's nothing. You just put together a D-Star repeater, out you go. Okay? If it works, and you're done. And that's really the problem I have, is at least just from a diagnostic standpoint, how do you split the problem? So I think it's a good point.
A prototype repeater that we're using in the Raleigh, North Carolina area adds a bit error rate report to the echo function. So that kind of it's a snapshot of your bit error rate. It's not a continuous look at it.
Okay.
But you talk into the repeater, it echoes back. Your display shows the bit error rate.
Now, is that part of D+?
No, that's a prototype controller.
Ah, okay.
So it's not on the market yet. The guy who built it is working on getting it on the market. Okay. But it's the kind of thing that is going on in the background there that people are working on.
Well, I'm glad to hear that. You know, I had mentioned that to Robin A4RC at I think the last Dayton or whatever, and you know, he mentioned the dongle I guess apparently he's tied in some stuff for doing a bit error rate test, but
Yeah.
I'm just saying as part of a general capability. You know?
The dongle gives you a continuous look at the bit error rate of every signal that you're looking at.
Yeah, yeah.
Which is interesting, but if you're walking out in the field, yeah, it's not going to do any good for you.
Yeah. Okay, well, thanks for pointing that out. Okay, any other questions? Okay, let me turn this back over to Bob here and